Right, hi everyone. I think we are live. Perhaps you could hit the like button or say something in the chat box if we are all connected. Right, good afternoon, good afternoon. I think that we are live in a moment or two. Right, good afternoon everybody. I think that we're live. If you could say something to me in the chat or hit the like button, then that would be great. Okay. Is there anybody there? I can hear, so I can see a few likes now. Perhaps you could say something to me in the chat if you are connected okay. I'm going to try and share the screen and see what happens. I know you can't see it at the minute, so don't worry about that. Okay, I have, there we go. I think, there you are. I suspect you can now see the screen. So perhaps you could hit like to tell me that you can see the screen okay. And perhaps somebody could just say in the comments, yes, I can see the screen. It took me eight minutes to share it successfully last time. I'm thinking that you can see the screen. Hi, Joe. If somebody could just confirm for me. Yep, good. The screen is live. Excellent. Right, well, it's 1 minute past 3. I think we just might wait a minute or two for everyone to arrive. Can I just say a couple of things before we start? First of all, thank you very much to everybody who sent in all these questions. However, I have to say that the questions that you've sent in are all pretty tough. So this is the day before your paper 2. We are going to look at some really very difficult questions in the next hour or so, because those are the ones you've sent in. So if you're finding these questions tricky, then don't panic about your day tomorrow, because even if you pick up some part marks on these hard questions, that's going to stand you in good stead, because remember, there are about 10 marks between each grade. Okay, so any part marks will be good. And of course, if you manage to sort out any of these questions completely, then you'll be hitting that top grade. Now, it may well be that some of these topics have appeared in paper 1. Remember, any topic could appear twice. And also, I decided to go with the questions that everybody had sent in. So we've got a couple of questions on indices. And yes, I know they were in paper 1H. They weren't in paper 1HR, I don't think. So we're going to do them anyway. And then we will move on to the other topics. Now, what topics have we got? We've got indices, circle theorems, vectors, probability, coordinate geometry, differentiation, graphs, and simultaneous equations. Okay, because those were the topics which were sent in. So I reckon that we're going to make a start with this question here on indices, which is question 24 on a paper, so is not going to be straightforward. And I will be quiet for a minute or two while you jot down the question. And if I were you, I would be writing everything in terms of powers of 3 and powers of 2 in base 2 and base 3. Right, go on, write it down, have a go. Okay. Right, so if I were doing this question, I would change that 18 into 2 9s, so 2 times 3 squared, and then that square root of 27, well, 27 is 3 cubed, so that's a square root of 3 cubed, and that's the power of 4n plus 6, and that is all over 2 times 3 is 6, and 9 is 3 squared. So I've got 3 squared raised to the power of 2n plus 8. and that equals 3 to the x. Now notice that I'm just doing one step at a time, because if I run into trouble with this question, I know that I'll get part marks for every step I do correctly. So far so good. Right, now I'm going to cancel these 2's. So they've gone. So I'm just going to be left with powers of 3 now. Now on the numerator there, I've got 3 squared, and I've got the square root of 3 cubed. So that's 3 to the power of 3 over 2 raised to the power of 4n plus 6. And that's all over 3 times. Now here, I've got 3 squared raised to the power of 2n plus 8. So that's going to be 3 to the power of 2 times 2n plus 8, 4n plus 16. And that all equals 3 to the x. Okay, looking good. Now on the top, I have got 3 squared multiplied by 3 to the power of 3 halves raised to the power of 4n plus 6. So that's going to be 3 to the power of 3 halves multiplied by 4n plus 6. So that is 3 to the power of 3 halves times 4n is 6n, and 3 halves times 6 is 9. And that's all over. Now what's this going to be here? I've got 3 to the power of 1. I'm looking here now at the denominator. I've got 3 to the power of 1 multiplied by 3 to the power of 4n plus 16. So I'm going to add those, which is going to give me 3 to the power of 4n plus 17. And that equals 3 to the x. All right. So on the numerator here, I'm going to add the indices. So that gives me 3 to the power of 6n plus 11 over 3 to the power of 4n plus 17, and that equals 3 to the x. So now, if I was going to divide those expressions on the left, if I do that yellow expression divided by the blue, I subtract the indices. So I'll have 6n plus 11 minus 4n plus 17. That will be what 3 to the power 3 is to the power of, and of course that will equal x. So I get 2n minus 6 equals x, or x equals 2n minus 6. And that gives me x in terms of n, which is what the question asked for. And that's that first question done. Okay. All right. So that is an example of a pretty tricky question on indices. And we've got one more to do before we move on to circle theorems. Okay. Right. Here we go. It's another question from later in the paper here. It's a question 26. Now, I have got some 10s, some 2s, and some 5s, and a 20. So I'm going to write everything in terms of 2s and 5s. Okay, so I'll be quiet for a moment, let you get a head start, but see if you can write each of those expressions in terms of 2s and 5s. Okay. Right, I'll have a look at the comments while you're making a start on that question. Right. Okay, now, if this is a topic which you find tricky, then don't worry about that. All of these questions which everyone has sent in have been all quite feisty grade 9 questions. So this is going to be quite a tricky hour because most of the questions are grade 7, 8, and 9. But any part marks you can pick up will stand you in good stead. And if you're going for that top grade, with luck, you'll be able to solve or get very close to solving these questions. Okay. All right, now let's have a look at the numerator here. I've got 10, which is 2 times 5. So I've got 2 times 5 to the power of 4n multiplied by 2 to the power of 3 lots of n squared minus 5n. So that's 2 to the power of 3n squared minus 15n multiplied by 5 to the power of 2 lots of 1 minus 2n. So that's 2 minus 4n. And all of that is over 20 squared. Well, 20 is 2 times 2 times 5. So 20 squared. Now, even writing that would get you a mark, okay? And in an exam where there are 10 marks between each grade, every mark counts. Right. I am going to simplify that further now. So I've got 2 to the power of 4n multiplied by 5 to the power of 4n times 2 to the power of 3n squared minus 15n times 5 to the power of 2 minus 4n. And all of that is over 2 squared times 5 squared. Okay. Right, I've got on the numerator here 2 to the power of 4n and 2 to the power of 3n squared minus 15n, and I'm multiplying those, so I'm going to add the indices. So that is going to be 2 to the power of 3n squared minus 11n times by, now these 5s here, 5 to the power of 4n and 5 to the power of 2 minus 4n. Well, that just gives me 5 to the power of 2, adding those indices. And on the denominator here, I've got 2 to the power of 4 times 5 squared. And I know, by the way, that this fraction equals 1. Right. Okay. I can cancel the 5 squareds. So I've got 2 to the power of 3n squared minus 11n divided by 2 to the power of 4. So that's 3 to the power of 2 to the power of 3n squared minus 11n minus 4. And that equals 1. Okay. Right, so that would imply that 3n squared minus 11n minus 4 equals 0. And there's a quadratic equation you can solve for n. Okay. If I was solving this for n, I would probably look to factorize it, but you could definitely use the formula. I know if I'm factorizing, it's going to be 3n. I know they've got to multiply to minus 4, so a bit of fiddling around gets me 3n plus 1 and 3n minus 4. So n would be minus a third or 4. And those are my two answers for n, but you could have used the formula at that final stage. Okay, and that is that question sorted out there. Okay. Right, so those are two questions involving indices. They're both quite feisty questions, but after all, that's what you sent in. So we're going to move on now to circle theorems. And there's only one question on circle theorems sent in, which was this one here, which does involve the intersecting chord theorem and also involves surds. Again, it's not an easy question. It's number 26 on a paper. So in answer to your question, Sophia, is this a 6-mark question? I don't know how many marks it was, but it's going to be 4, 5, or 6 marks at the very least, I would think. Okay. Right. Okay, now, Will, I'm not going to do any questions off the cuff. I'm just doing questions which people have sent in. Okay, so we know, the questions I'm doing are the questions that people have already sent in. Those are the questions we're going through now. If you want to come this evening, then I'm looking at questions, some of which are easier and some are more difficult, all on predicted topics. Okay, but for now, we're just doing the questions people have sent in. Somebody asked for a link to the 100 IGCSE maths questions. If you find the film on the channel, there's a link in the description, I think. So that'll answer that one. Okay. Deadline for signing up this evening. Well, I'll send out the questions about 5, about 5:30, perhaps. So maybe make sure you've signed up by then. Okay. Right, I'm just going to have a look back at the comments, see if anybody else has asked a question I can answer while people have a go at this intersecting chord theorem. Now, intersecting chord theorems are probably the hardest theorem, but the nice thing about it is that you can easily see that it involves the intersecting chord theorem. Okay. So, Joe, you said, are there any easier questions? There are lots of easier questions on the paper. It's just that for this live session, the questions which were sent in are all pretty tough. So you might be better off, if it's easier questions you're after, not being here this afternoon and coming instead to the session this evening. Okay, the 100 Days PDF is the link is on the description of the film. Okay, so you can find it that way. Right. So, intersecting chord theorem on question 26 here. Okay, so here's my way of remembering the intersecting chord theorem, and you may or may not like this, but I'll tell you what it is anyway. Now, what I tend to do to remember it is that I would call one of the chords AB and the other one CD, and call this point P or something like that. And then I simply go A, B, C, D, alphabetical order, put a P after each one there, and then times equals times, and that is the intersecting chord theorem there. Okay, so it's the length of AP times the length of BP equals CP plus DP. Now in this question, of course, they're using different letters for the different points on the circle. I'm going to stick to what I've written there since I've changed it on the diagram. Okay, and it says here, show that the length of AB is P root 5 plus Q. Well, AB is still called AB, so it should be fine. Right. Okay. So, A to P, I'm going to leave that just as AP times BP is 2 plus root 5. And that's going to equal CP, which is all the way from C to P. So I'm going to add 4 plus root 5 and 2 more root 5s. So CP is going to be 4 plus 3 root 5. And I'm going to multiply that by DP. And DP is 2 root 5. So there is everything that's substituted into the intersecting chord theorem. Okay, well, I simply renamed the point of intersection P because that's how I remember my intersecting chord theorem. Right, so I'm going to have AP multiplied by 2 plus root 5, and that is going to equal 4 times 2 root 5, and multiplying up this bracket here is 8 root 5, and 3 root 5 times 2 root 5 is 6 times 5, 30. Okay, so that means that AP is 8 root 5 plus 30 divided by 2 plus root 5. Now, I need to give AP in this form, P root 5 plus Q. So I'm going to need to rationalize the denominator here. So I'm going to multiply top and bottom by 2 plus root 5. Now, surd certainly came up in one of the paper ones. I can't remember which paper one it was. But the intersecting chord theorem, I don't think that came up in either. So at least this serves as a revision of that. So I'm going to do the numerator times the numerator, 8 root 5 plus 30 times 2 root 5. So this is what I'm doing, 8 root 5 plus 30 multiplied by 2 minus root 5. Okay, so I'm going to have 16 root 5 minus 40. Now I'm doing 30 times the 2 plus 60, and 30 times minus root 5 gives me minus 30 root 5. And then on the denominator here, I'm just going to have 4 minus 5 minus 1. So on the numerator, I have got minus 20. Have I got minus 20? No, I haven't. I beg your pardon. I've got plus 20. I've got 20 minus 14 root 5, and on the bottom I've got minus 1. So that gives me 14 root 5 minus 20. Now let's have a quick look at the question. Show that the length of AB is p root 5. Well, I haven't found the length of AB yet. I've found the length of AP all the way. So let me write that up here. I found that AP is 14 root 5 minus 20, and I'm interested in AB. So AB is going to be AP, 14 root 5 minus 20, subtract the length of BP, which is going to be minus 2 plus root 5. So my answer is going to be 13 root 5, and I have minus 20 minus 2 minus 22, and that is my answer for AB there. So thank you, whoever sent in that question. It wasn't a straightforward circle theorems question. Okay. All right. Okay, so that is that circle theorem question. You'll be able to run through it again when the recording of the live appears shortly when we've finished, okay, shortly after we've finished. Right, vectors. Okay, 2 vector questions. This is the first. It's a question 23. So again, I'm afraid it's not an easy question. Okay, but there it is. Have a go at it while I look back at the comments and see if there's anything I can answer. If you're looking for a copy of the 100 Days PDF, send me an email and I'll email it through to you. If you want the link to sign up for the evening session, then send me an email and I'll email you through the link as soon as we've finished. Okay. Square root of 41, that's correct, or that's what I've got. Okay, all right. Let's have a look. I would start by drawing a diagram for this question. Okay, so I would start by drawing a trapezium. So I'm going to have A, B, C, D. And now I'm going to mark on the trapezium the information that I'm given. It tells me that D to A is minus 2, 3. And it tells me that D to B is minus 1, 7. Okay, and I'm also told that DC, the bottom, is 3 times the top. Okay, so that's all the information that I've been given. Okay, and now I'm going to set about finding the exact magnitude of BC. Now to start with, I'm going to find AB, because that will enable me to find DC. So I'm going to find AB to start with. Now AB, if I was traveling from A to B, then I would go from A to D, and then I'd go from D to B. So that's going to be A to D is going to be the negative of D to A. So that's going to be 2 minus 3. I'm going to add on D to B, so I'm going to add on minus 1, 7. So the vector AB is the vector 1, 4. And that means that the vector DC is 3 times that, so it's 3, 12. So now I'm just going to add those to my diagram here. 1, 4, 3, 12. Okay. Now I'm asked to find the exact magnitude of BC, so I'm going to need to find BC. Okay, so let's find BC. Now if I was going from B which is here, to C, which is here, I would probably go from B to D and then from D to C. So I'm going to do BC is B to D and then D to C. Now B to D is 1 minus 7 because it's the negative of D to B. And now D to C is 3, 12. So I can add those vectors up to give me 4, 5. So BC is the vector 4, 5. And in the question, I'm asked to find the magnitude of that. So that'll be the square root of 4 squared plus 5 squared. And hence, whoever it was who said the square root of 41 is absolutely right. Okay, and the question here says find the exact magnitude. So I'm going to leave my answer as the square root of 41. Okay. All right, that is question 3. Okay. Sorry, question 23, I beg your pardon. All right, and now the second vector question, which we're going to look at, is again one which was sent in, which is one that involves ratios. So I'm just going to give you a couple of minutes to look at that. Okay. All right, I agree with you that that is an okay question 23. In answer to your question about lambdas and mu's and x's and y's, I always tend to use lambda and mu's because that's what we use in sixth form and in degree level maths. So that's how I always use lambda mu's. You can use x's and y's. They simply stand for a fraction. And we're going to do a question in a moment, question 21. Here it is, in fact, where we need to deal with fractions of a ratio. And so you might want to use x and y. You might want to use mu and lambda. Okay, here's question 21. Those of you who have watched my vectors video will have seen me solve about 6 or 7 of these, one after the other. And once you've solved 6 or 7 of them one after the other, you get to be you get to find them much easier than before. Right, there you are. Have a go at that question, and I'll look back at the comments. We are going to look at simultaneous equations, yes, because somebody sent in a question on simultaneous equations, so that's coming up. The topic called where you find the values of x and y for a graph, just plotting graphs, I guess, plotting nonlinear graphs. Graph transformations. I don't think we are. I'm afraid. I can't remember if there's a question on graph. Oh, there is a question on graph transformations coming up. Yes. Okay. We are looking at perpendicular lines. Yes, because we're going on to coordinate geometry. Okay. Right. Now, this is not a straightforward question. Question 21. There never are. Okay. And the trick for these questions is as follows. Let me take you through the beginning of this question and then what the trick is, and then I'll let you try and work it through. Okay. So you've got a triangle, and Q is the point on AB such that OQP is a straight line. So the point is that this point Q is on 2 straight lines. Okay. It's on the straight line OP. So I'm just going to draw that now. Q is on the straight line OP. And it's also on the straight line AB. We don't know how far it is along either of those lines. So we're going to make an assumption. Let me show you. I'm going to split my page into 2. Because on half of this page, and because I've labeled that in yellow, I'll label this in yellow here, right? On this side, I'm going to use the fact that the point Q lies on the line OP. Now, I don't know how far away it is along the line OP. So I'm just going to say that O to Q is lambda OP. And lambda is just a fraction. I don't know, Q might be half the way along OP, in which case lambda would be half. Or it might be 2/3 of the way along, in which case O to Q would be 2/3 of O to P. And that's going to be one of my bits of working there to the right-hand side there, where I use the fact that Q is on OP. Right. The next thing I'm going to do, once I've worked that through, is I'm going to use the fact that Q is on AB. Now again, I don't know how far along Q is on AB. So I'm just going to assume that from A to Q is mu of the way along AB. Now again, mu is just a fraction. I don't know how far along Q is on that line. Maybe it's about 1/3, in which case mu would be 1/3. But who knows? It doesn't matter for the moment. Okay, so I am on the left-hand side here using the fact that Q is on the line AB. And on the right-hand side, I'm using the fact that Q is on the line OP. Now, on both sides, I'm going to write an expression for the vector of O to Q. So on the left-hand side, if I'm using the fact that Q is on AB, then I'm going to go this way. I'm going to go up to A and then down AB. So on the left-hand side, I'm going to do OQ is OA plus AQ. Okay? And on the right-hand side, I'm not using that blue line at all. I'm just using this bit. So I'm just doing OQ is a part of the way along OP. Now you need to follow both of those directions down, both of those bits of working down, and find two expressions for OQ. Okay, one of the expressions will have a mu in it, that's on the left-hand side, and the other expressions will have lambdas in it, that's on the right-hand side. Okay, now I'm going to start on the left. Okay, so OQ on the left is OA plus AQ. So OA is 4A and AQ is mu of AB. Okay, so that is 4A plus mu times AB. Now what is AB? Looking at my diagram at the top, AB is minus 4A plus 6B. I'll just write that as 6B minus 4A. That's the vector AB. So now I'm going to multiply out this bracket, 6 mu B minus 4 mu A. Now, later on, I know I'm going to have to use the coefficients of A and the coefficients of B. So I'm actually going to write this as 4A minus 4 mu A, get my A's together, plus 6 mu B. And then I'm going to factorize these two here, because then I've got the coefficient of A all ready for me to use in a moment. Okay, so on the left-hand side of the screen there, I have used the fact that Q lies on AB, and hence I have an expression here for OQ. On the right-hand side, I'm going to do exactly the same. I'm going to find an expression for OQ, but this time I'm using the fact that OQ is part of the way along OP. So I need an expression for OP, really. Well, what is OP? Well, in the question here, it tells me what AP is. So to do OP, I'm going to go O to A and then add on A to P, and that'll get me from O to P. So that's going to be lambda. Now OA is 4A and AP is 2A plus 8B. I know that because it tells me in the question. So that is lambda 6a plus 8b. Okay, let's multiply out that bracket. 6 lambda a plus 8 lambda b. Now I have two expressions, one on the left, one on the right, and both of those expressions are for the same vector. They're both for the vector OQ. Well, if this is an expression for OQ and this is an expression for OQ, then both of those expressions must be equal. Now, if both of the expressions are equal, then they must have the same amount of a's in them and the same amount of b's. So the coefficient of a on the left must be equal to the coefficient of a on the right. And the coefficient of b on the left must be equal to the coefficient of b on the right. So I have written the coefficient of a from the left equals the coefficient of a from the right. My shading's just gone wrong. There we are. And similarly for the coefficient of b. And now I have two equations there, which I can solve to find mu and lambda. Now, it doesn't matter how you solve those two equations. You can solve them in all sorts of different ways. You know how to solve simultaneous equations. I'm going to multiply this one here by 4, the top one by 4, and the bottom one by 3, because that's going to give me 24 lambda in both of them. Okay, but there are many different ways you can do it. If I multiply the top one by 4, I get 16 minus 16 mu equals 24 lambda. And if I multiply the bottom one by 3, I get 18 mu equals 24 lambda. So that means that I can write 16 minus 16 mu equals 18 mu, because both of those expressions equal 24 lambda. Add 16 mu to both sides. 34 mu equals 16. Mu equals 16 divided by 34, which is, divide top and bottom by 2 8/17. Okay. Now, let's go up to the question and see what the question is asking us. By the way, I could work out lambda as well, of course. Perhaps I should do that just for completeness. So mu is 8/17, and I know that 6 mu is 8 lambda, right? So 6 times 8/17 is 8 lambda. So therefore lambda is 6/17. Great. Okay, so I've worked out mu and lambda. Right. What was the question? Let's have a look and see what the question was. The question was, using a vector method, find the ratio of AQ to QB. Now, look at the left here. I said that OQ was going to be equal to lambda OP. All right, and I'm supposed to be finding the vector of, that's not going, sorry, I've got that wrong. I've got my values of lambda and mu correct, but the question is about the ratio of A to Q to Q to B. Okay, so I'm going to use the fact that I called AQ mu AB. And now I know mu, of course. I know that AQ is 8/17 of the way along AB. So if I draw A to Q to B, then I know that Q is 8/17 of the way along, which means that from Q to B, that must be 9/17 of the way along. So the ratio of AQ to QB is 8 to 9. And that is that vector question done. Question 21. Okay, not easy. So thank you, sort of, whoever sent that in. Okay. All right. Again, you can rewatch that on the recording of the live stream when it appears. But rather than staring at it now, I think we best move on. Okay. Right. Probability. Here is the one of the probability questions that was sent in. So this is the one we're going to do. Is it large enough for you to read it? Yes, I think it probably is. Right. Okay. Have a go at that, and I'll have a look in the comments. May, these topics are a mix, really, of those which we think will come up in 2HR and which we think will come up in 2H. They're actually questions that people sent in. But of course, we don't know. Every topic could come up, couldn't it? All right. Why is it 8/17? Okay, crikey. I tell you what, I'm not going to go back to that now. I'll let people have a go at the probability question. If we have time, maybe we'll go back and look at that vector question at the end. Okay. All right. Well, we're going to do coordinate geometry. So to the person who's asked about coordinate geometry, that's coming up straight after probability. Okay. Probability seems to occur in every paper. So you would expect probability to occur twice or maybe 3 times across your 3 papers. Having said that, we have no idea what's going to come up. Okay. But it's certainly worth being on top of probability because it's one of those topics that seems to come up all the time. I agree with you, whoever it is who's talking about OCR versus edexcel and all the rest of it. You're right, maths is maths. And I sat with somebody the other day and did an OCR paper with them, and it was all the same stuff. Now, I really like this question 18 because you can do it in a long way or you can do it in a short way. Well, maybe the short way is to say, is to do the probability of something not happening. You might be doing it the shorter way, but there are fewer possibilities to worry about if you deal with, in this case, the probability of not getting lemon rather than the probability of getting either of the others, I think. So in this question then, we've got 16 sweets, 4 are blackcurrant, 5 are lemon, and 7 are orange. And basically 3 people each take a sweet out of the bowl, right? So this looks to me like it could be a kind of tree diagram question, with the first person taking blackcurrant, lemon, or orange, and then I guess the next person is going to come from here or from here or from here. This is not the way I recommend, by the way. And then the third person, right? And so you're going to end up with 27 different outcomes here, and a kind of impossible tree diagram to get to grips with, I think. So let's just have another think about this. Now we're asked to work out the probability that 5 lemon sweets are still in the bowl after they've each chosen a sweet. Now it starts with 5 lemon sweets. So if at the end of the day we want 5 lemon sweets to still be in the bowl, what we're being asked for really is for none of them to choose lemon. Okay, we want none of them to choose lemon. So I'm going to do this for my tree diagram. I'm going to say the first person chooses lemon or not lemon. And then I'm not going to bother with the tree diagram up here with this bit, because once I've chosen lemon, then I'm no longer interested. Okay. So if the first person chooses not lemon, then the second person, up they come, and I want them to choose not lemon again. And then the third person, I want them to choose not lemon. Now there's really no point in me exploring the rest of the tree because I'm only interested in the probability of the first person choosing not lemon, the second person choosing not lemon, and then the third person choosing not lemon. Because that's the only way there are going to be 5 lemon sweets still in the bowl. Okay? So this is my short way there, okay? So the probability of the first person choosing not lemon is, well, there are 11 not lemon out of 16. So that's the probability of this first person choosing not lemon. Right, now let's imagine that they choose not lemon. Now the next person steps up to the bowl, okay, and they're going to choose a sweet. There are 15 sweets left now, aren't there? And 10 of them are not lemon. And then when the third person comes up to the bowl, there are 14 sweets left, and 9 of them are not lemon. So the probability, what we're really being asked here to work out is the probability of the first person choosing not lemon, the second person choosing not lemon, and then the third person choosing not lemon. So really, we could simply do 11 sixteenths times 10 fifteenths times 9 14ths, okay, which you can work out on your calculator. Okay. Now, I don't know what the question was in Sophia, and I don't know what the question was in paper 1H. Maybe you did well to draw the tree diagram. I just don't know. Okay. Now, I haven't worked out this answer now, so I'll do it on my calculator. 11 over 16 times 10 over 15 times 9 over 14. Well, I get 33 out of 112 for my answer. Okay. Could you do the probability of all lemon? I'm not quite sure why you'd do that, because if you then did 1 minus that, then the outcomes you were left with would include 1 lemon or 2 lemons. So I'm not sure that would help you in this case. Okay. Right. There's a question about did I find the wrong ratio in the vector question? I don't know. I don't know. We'll go back to it at the end. Okay, that's the probability question. So, coordinate geometry. Right. We've got 2 questions on coordinate geometry to do. Okay. Now, if this wasn't just a question and answer thing, I guess I'd take you through the different things that you need to be able to do to answer coordinate geometry questions. But it's not a teaching session. It's just a let's go through these questions session. So I'll leave you for a minute to have a look at that question. My big hint would be to draw a diagram. Okay. Again, I don't think you can do the probability of 1 minus all lemon. Okay. Oh, I think I've already answered that, haven't I? Draw a diagram. Okay, now somebody's just sent an email saying, could I go through some additional questions from the June 23 paper today? I will do if I get the chance. Okay. And I will certainly send the link to whoever it is who's just emailed me about the 100 days PDF. I can send that to you after the session. If any of you want to come this evening when I'm going through a whole load of questions on the predicted topics, but some of them are easier and some of them are more difficult, there's much more of a spread of questions this evening, then send me an email and I'll send you the link to that. Okay, here's my not very good diagram of a kite. I'm going to draw the diagonals. What you need to know for this question is that the diagonals of a kite are at right angles to each other. They're perpendicular. Okay, I'm going to label A, B, C, and D. Now I'm told the coordinates of A are -3, 4. I'm told the coordinates of M are 0, 2. I'm told that AB and AD are both 6.5 centimeters. And I'm told that the x coordinate of B is positive. So I bet that's going to help me categorize two answers later, because I imagine I'm going to get one positive and one negative answer. Okay. And I'm asked to find the coordinates of B and D. Right. Okay. So I know two things about the points B and D. Okay, I know that the points B and D, I know they lie on this line. Look, I know they lie on the line BD. So my kind of one criteria for B and D is that they are on the line BD. So if I can find the equation of the line BD, then I know that I've got a condition about the coordinates of B and the coordinates of D. The other thing that I know about the points B and D is that they are 6.5 centimeters away from A. So I know that the distance from A to D is the same as the distance from A to B, and I know that that is 6.5. So that's another condition. And each of those two conditions are going to give me an equation, and then I shall solve my two equations simultaneously. All right. Now, first of all, we're going to look at this blue condition, which is about the fact that both the point B and D lie on the line BD. So your mission really is to find me an equation for the line BD. Okay, that's the first thing you need to do. We need to find an equation for the line BD. Now, to find an equation for the line BD, we need to know the gradient of BD, and we also need to know a point on the line. So we need to know the gradient and a point. Well, I know a point on BD already, because BD goes through the point M there. Okay, so I already know a point on the line BD, and that point is 0, 2. Now, what about the gradient of BD? What about the gradient of this line BD? Well, I do know it's perpendicular to the line AC. So if I could find the gradient of the line AC, then I could find the gradient of the line DB. And I can find the gradient of the line AC, AC, because I've got the point A, which is -3, 4, and I've got the point M, which is 0, 2, so I can find the gradient of AM, which is the same as the gradient of AC. So to find the gradient of AM, I'm going to do rise over run. I'm going to get -2 over 3. So the gradient of AM is -2/3. So the gradient of BD is the negative reciprocal of that, 3 over 2. Now, I can find the equation of the line BD now, because I know its gradient and I know a point on the line. So I know it's going to be y equals mx plus c, y equals 2/3 of x plus c. And now all I have to do is to find c. And I know that the point on the line is 0, 2. So I can put in y is 2 when x is 0. So 2 is 3/2 times 0 plus c. Look at that. So c must be 2. I kind of knew that because the point they've given me is the y-intercept, isn't it? But that's just coincidence. So now I know the equation of the line BD. The equation of the line BD is y equals 3 over 2x plus 2. So that's the first condition for both of these points, that they lie on the line y equals 3/2 of x plus 2. Right, the second condition is about the distance from A to D and A to B. Okay, right. I'll do this in black here, in black ink, so number 2 here. Let's call my unknown points D and B, let's call them x, y, x, y. And I know that the point A has coordinates -3, 4. So I can write an expression for the distance between those 2 points. Okay, the distance between those points, I'm going to use Pythagoras, and the distance between those points is the square root of the difference between the x coordinates squared plus the difference between the y coordinates squared. So it's the square root of x minus -3, so x plus 3 squared, plus y minus 4 squared. So that is an expression for the distance between A and our mystery points, and we know that that equals 6.5. And this is going to be the second equation in x and y. Now, I'm going to need to simplify this quite a lot. By the way, if when you're working through this, if you made a mistake, like you didn't do -3 or something like that, you made a mistake somewhere, keep on going. If you know the method you're following, then keep on following the method. Because the bottom line is, if you make a little numerical mistake, you're only going to lose 1 mark if they can see when they mark your paper that you know what you're doing. Right, I've got this black equation here, and I'm going to continue to simplify it. Okay. Right. I think here we go. Right, so I'm going to square both sides. So that's going to give me x plus 3 squared plus y minus 4 squared equals 6.5 squared. Well, 6.5 squared is 42.25. Now, if I call this red equation, equation 1, and I call this black equation, equation 2, do you see how I've got a pair of simultaneous equations here? I've got the black equation, and I've also got the red equation, y equals 3/2 of x plus 2. So why don't I just get this expression for y and substitute it into that black equation? Get equation 1 and substitute that expression into equation 2. Equation 2 would then be x plus 3 squared plus y, which is 3/2 of x plus 2 minus 4 squared equals 42.25. Okay, I suppose it would be best if I put a square bracket here. So that is going to be x plus 3 squared plus 3/2 of x minus 2 squared equals 42.25. Now I've got an equation just with x's in it here, so I think I can solve this. Now, when I multiply out the x plus 3 squared, don't forget it's x plus 3 times x plus 3, so it's going to be x squared plus 6x plus 9 plus, now this bit here, don't forget that that is 3/2 of x minus 2 multiplied by 3/2 of x minus 2. So it's going to be 9/4 of x squared. Then I'm going to get minus 3x's and another minus 3x's, minus 6x plus 4 equals 42.25. Now, I'm just going to multiply everything by 4, I think. So it's going to give me 4x squared plus 24x's plus 36 plus 9x squared minus 24x's plus 16 equals 42.25 times by 4. I almost forgot to times that by 4. 169. Okay, let's tidy up the left. I've got 4x squared and 9x squared. So I've got 13x squared. I've got plus 24x minus 24x. So they're out for the count. I've got plus 36 plus 16, so I think that's plus 52. And that equals 169. Minus 152 from both sides. 13x squared equals 117. Divide by 13, and x squared is 9. So x is plus or minus 3. So there are my two values for x. And now I can find out y. Y is going to be 3 halves of x plus 2. So if x is minus 3, then y will be 3 halves times minus 3 plus 2. You could put that into your calculator, of course. It's going to be minus 4.5 plus 2, so it's minus 2.5. So that is the point minus 3 minus 2.5. And similarly, if x is 3, then y will be 3 halves times 3 plus 2, which is 4.5 plus 2, 6.5. So that's the point 3, 6.5. Now, which is which? Remember, we were finding the coordinates of 2 points, D and B, and in the question it says that the x-coordinate of B is positive. So clearly B must be 3, 6.5, and D must be minus 3, minus 2.5. And there you have it. That is the answer to that question, question 22. Okay, and that's how you work it out. It's not an easy question. All right, the chat's gone very quiet, so I hope you're all okay. All right, we set up two conditions for the points B and D. One of them about the fact that they lay on the line BD, and we could find the equation for that line, and the other one about the fact that they were 6.5 away from A. All right. Now, that's the sort of question that if you didn't get it, there's loads of part marks for you there. Okay. Right, the chat is still quiet. So I'm going to move us on to the second coordinate geometry question. Okay. Right. Okay, here we go. So, question 24. Okay, you've got some information there about two straight lines, L1 and L2. Okay. I'll let you have a read of the question and make a start on that. formulas for square-based pyramid and stuff, aren't they on the front of the paper? Anybody who missed the question on that last paper, you need to watch my film about that, my Dara thing, where you check you've done each question before you check that you've answered each question, and then you check whatever the R was and whatever the A was. Okay, the session tonight's at 6:30. If you send me an email, I'll send you the link to it. Okay, I'll put my email address in the chat now. Oh, well, my email address is in the description anyway. But here, I'll type it in anyway. Oh, I've typed in the email on my son's user, so that's why it's come up with that weird BCF thing, BFC thing. Okay, should we have a look at this question? Now remember, this is all these questions. Look, this is number 24, right? So all of these questions for many of you is probably going to be a question of getting as many marks on it as you can. And if you solve it, then that's great. But if you don't, you'll have picked up part marks. Okay. All right. For some of you, I guess, you'll be wanting to get full marks on these last questions, which is absolutely fine as well, of course. Right. Okay. So L1 and L2 as two straight lines. Fine. Here's the equation of L1. By the way, now I've got the equation of L1, here it is, I could write that in the form y equals and get its gradient, couldn't I? So I'm just going to do that. So that is y equals a half minus a half x plus 0.8. All I've done there is rearrange the equation of L1, because then I can easily read off what the gradient of L1 is. Okay. Right, let's have a look. L2 is perpendicular to L1. Oh, great. Okay, well, I know the gradient of L2 then, don't I? Because I know the gradient of L1. Let's write down what do we know about L2. Well, we know its gradient. The gradient of L1 is minus a half, so the gradient of L2 is a negative reciprocal of that. So the gradient of L2 is 2 over 1, or 2. And look at that. I know a point on L2 as well. I know that L2 passes through the point 8,6. Okay. Well, then I could work out the equation of L2, couldn't I? So I'm going to work out the equation of L2. It's be y equals the gradient times x plus c, and I'm going to use the point 8,6 to work out what c is, because I know that when x is 8, y is 6. So I know that 6 equals 2 times 8 plus c. So I know that 6 is 16 plus c, so I know that c is minus 10. So now I know that L2 has an equation of 2x minus 10. Okay? All right, I'm just going to pause for a second, but I found the equation of L2. Okay, now it says L2 crosses the x-axis at the point A. Well, I'll tell you what, I'm just going to draw L2. Okay, here we go. Oh, what's on there? I've never seen that before. Let me try again. There we go. Right, so let's just draw L2. L2 is 2x minus 10. So it goes through minus 10 there as a gradient of 2. So it's going to be quite steep, isn't it? Okay, that is y equals 2x minus 10. Well, it's got a gradient of 2, hasn't it? So it's going to cross there at 5, because every time it goes 1 along, it goes 2 up. Okay. Right. L2 crosses the x-axis at the point A. Well, it looks to me then that the point A is the point 5, 0, because that's where L2 crosses the x-axis. Okay. L2 crosses the x-axis at the point A, and L2 intersects the straight line with the equation x equals -3 at the point B. Well, let's have a look. When x is -3, then what's the point on L2? It's y equals 2 times -3 minus 10. So it's y equals -6 minus 10, which is y equals -16. So I've got the point -3, 16. So that is the point B. Okay. I have a feeling that I've made a mistake. I'm just going to look in the comments. Have I made a mistake? Has anybody found it? Why is it 5, 0? I think I've got that wrong. Let's have a look. No, I think that's looking good. Okay. I think I've got L2 as being L2 crosses the x-axis at the point A. Well, L2 crosses the x-axis here at 5, 0. So I've got to find the area of this triangle, the area of the triangle which goes from the origin, O, to the point A, which is 5 along, and then to this point B, which is at -3 all the way down here to 16. So I have to find the area of this triangle here. Okay, so the area of that triangle, well, the base is 5, the height is 16, so base times height, because that's the height there, base times height divided by 2. 5 times 16 divided by 2 is 5 times 8, 40. Right. So let me put that on there, and let's have a look and see what questions you've got in the comments. Okay. Well, it looks like you're kind of sorted in the comments. So I'm tempted to move on. Okay, so that is the end of coordinate geometry. 2 tough questions on coordinate geometry. Okay, and we're moving on to differentiation. Right. So here's a question which was sent in on differentiation. Now the person who sent it in has put a bit of their working there, so we'll cross that off. Okay, I think that must have been from a different question. Have a look at this question on using differentiation to find the maximum value of something. Differentiation did appear in paper 1, certainly appeared in 1H, but it was connected to finding the stationary points of curves, not to finding the maximum value of something like a surface area. Okay, thank you for everybody who's explained what I was doing in that bit I did too quickly. I got that 5 really by sketching the graph, and it was 10 down, and I knew it had a gradient of 2, so I kind of knew that it wouldn't cross at 10 on the x, it would cross at only 5. Yes, that's how I did it, 2 up for every 1. Okay, we've got to find the maximum value of the surface area of this cuboid. So the first thing we need to do really is to write an expression for the surface area of the cuboid. Okay, now the surface area is the area of all the faces added up. So we've got the area of the bottom, which is x times x, and the area of the top, which is x squared as well. So that's the area of the top and the area of the bottom. Now the area of the side here, well, that side there has an area of x multiplied by 12 minus 3x, the length times the height of that rectangle. And of course, I've got 4 of those rectangles, haven't I? So the total surface area of this cuboid is 2x squared for the top and the bottom, and then it's 4 times x times 12 minus 3x. So before I do anything else, I'm just going to make this a bit simpler. So I've got 2x squared plus 4x times the bracket. I'll write that up here, 4x times 12 minus 3x. Well, that is 48x minus 12x squared. So I've got 2x squared plus 48x minus 12x squared. So the area, the surface area, is minus 10x squared plus 48x. So there's an expression for the surface area of the cuboid. And now you've simply got to find what value of x makes that a maximum. Okay? All right. Yes, this is for tomorrow's paper. I'm just going through questions which people have sent in. Okay? I know nothing about the business tomorrow. Please go and ask somewhere else about the business paper. Okay. Right, I've got to maximize this surface area. So I'm going to differentiate that with respect to x to find what value of x makes it a maximum. So I'm going to need to differentiate it first. Remember, it's the coefficient times the power. So it's minus 10 times 2. Minus 20, and knock 1 off the power, minus 20 times x, plus, remember that's x to the 1, so it's 1 times 48 is 48, and now it's x to the 0, so that just goes. So the differential is minus 20x plus 48, and I want that to be a maximum, so I'm going to set the differential equal to 0 and find what value of x gives me that maximum. And the answer is that the surface area is at a maximum when x is 2.4. Now the question is, find that maximum value. So I'm going to substitute in that value of 2.4 into my formula for the surface area. So I'm going to say minus 10 times 2.4 squared plus 48 multiplied by 2.4. I'm going to stick that in my calculator to get the answer, which is, as somebody said on the chat, 57.6 square centimeters. That's the maximum surface area of that cuboid. Why do I differentiate it instead of making it greater than 0? Well, I need if I simply got the surface area and made it greater than 0, I'd be finding any value of x which had a positive surface area. Well, I want the maximum surface area. Okay. Do we use differentiation when asked to find maximum or minimum or something? Yes, you do. You differentiate it and you set the differential equal to 0. Okay. All right. You can ask for tracing paper from the invigilator. Yes. Okay. No, you can't see my face. That's because the camera is pointing at the ceiling. But I promise I'm here. Differentiation gives you an expression for the gradient of something, and then you set it equal to 0, and that will give you the x value that gives you a maximum or a minimum. How would we do this to find the minimum point? You do exactly the same, but in the context of the question here, we were finding a maximum. So the only value we were going to get was the maximum. Okay, in year 12, we do much more distinction between maximum and minimums. In these papers here, if they say find the maximum, the answer you get for x will be a maximum when you set the differential. So in these questions, if they say find the maximum value of x, get the differential, set it equal to 0, and the answer you get for x will be the maximum, will give you the maximum. And if they say find the minimum value, then get the differential, set it equal to 0, and the answer you get for x will be the minimum. Okay, don't worry about it other than that. Okay. All right, I found the surface area by finding the area of the sides and adding them up. That's exactly what I did, yes. Okay, can we have another example of this type of question as if by magic? Here is question 15 that somebody else sent in, which is this time about maximizing the volume of a cuboid rather than maximizing its surface area. Okay, is the live later on about maths? Yes, it is. It's at 6:30. If you send me an email, I'll send you a link to the details. Okay, the live later on is me going through some questions on topics which we think will come up on paper 2. But these questions are all questions that you sent in. So all of you have sent in ridiculously difficult questions, whereas at 6:30 I'm going through a range of questions. Right, have a go at question 15 here. Okay, have a go at part A, which asks you to show that the volume of that cuboid is equal to that expression. And the expression that they're looking for you to find the volume is equal to is 28x squared minus 2x cubed. Okay. 6:30 British summertime. 6:30 isn't free, no, because it's on Zoom and it's on a paper I've written, but it costs a whole £10. Okay, and if you send me an email, I'll send you the link to the details. I'd do similarity if I've got time, okay? But I'm doing questions today that people sent in. This video is going to be saved. Yes, it'll be available on the channel under the live tab, probably as soon as we finish, I guess. The live stream at 6:30 is on similar topics, yes, but there are some easier questions and some more difficult questions. This just seems to be difficult questions. Okay. My email. What time does this live finish? Well, I'm hoping we're going to finish about 5:30. What's time? When did I start? Started at 3, so I'm hoping we're going to finish at 5. Okay, and we've only got graphs and simultaneous equations to do, so we probably will finish at 5. My email address is in the description of the film there, and I'll stick it in the chat now because that's probably easy for you. Okay. Which topics can we expect for 6 and T marks? I'm not sure what you mean, but I don't know which topics are going to come up in which place on the paper. So that would be a guess, I'm afraid. The live is on Zoom. If you send me an email, I'll send you all the details. You know what I mean. Okay, now, in this question, you have to find an expression for the volume of this cuboid. But look, the reason that I'm pleased that somebody asked to do this question is you see how part A says show that the volume of the cuboid is this expression. Okay, that's great. Let's imagine you couldn't do that. Okay, let's imagine that you did your best. You've got some working here. You'll probably get a mark or 2, but you haven't shown the volume equals that. But the nice thing about this question is it really doesn't matter, because look, the next part, part B, says find dv by dx, i.e. differentiate the volume. Well, they've told you that the volume is, they've told you that v is 28x squared minus 2x cubed. So you can still do part B and you can still do part C, even if you haven't done part A. Okay, so for this question, there are probably 8 marks. Well, you could still get 5 of them without doing part A. So just because you get stuck on part A of a question, don't let that make you think that you can't have a go at B and C. Okay. Right, having said that, let's see if we can't do part A. Now, right, here it says that the volume of this cuboid is v cubic centimeters and the length of the cuboid is y, and these are both x here, and it says the total length of all the edges is 112. And then it says show the volume of the cuboid is this expression here, and that expression doesn't have any y's in it. So I'm going to need to get rid of y's first of all. So I'm going to use this piece of information here. The total length of all the edges is 112. Well, the total length of all the edges, let's have a look. There's an x, an x, and an x, and an x, and an x, and x, and x, and an x. So there are 8 x's. And there are some y's. 1, 2, 3, 4. There are 4 y's. So the total length of all the edges is 8x plus 4y. And you know that equals 112. So use this to get an expression for y. Okay? That tells you that y is 112 divided by 4 is 28, isn't it? Let's have a look. 112 divided by 4 is 28. So y is 28 minus 2x, right? So y is 28 minus 2x. So now let's get an expression for the volume, shall we? The volume would be the length, 28 minus 2x, times the width, x, times the height. Now let's simplify that. That is x squared times 28 minus 2x. That is, multiply out the bracket, 28x squared minus 2x cubed. And that's what they said, look. So we have shown that the volume is equal to 28x squared minus 2x cubed. But it wouldn't matter if you hadn't managed to do that, because you can still do part B. Okay, I'm going on to part B. It says, find dv by dx. So I've got v, I need a bit more room, I'm going to do it here. I've got v equals 28x squared minus 2x cubed. So I'm going to differentiate that with respect to x. 2 times 28 is 56, knock 1 off the power. 2 times 3 is 6, x squared, knocking 1 off the power. So the answer to the question here is that dv by dx is 56x minus 6x squared. Good. Find the maximum value of v. Give your answer correct as 3 significant figures. So I'm going to put my differential equal to 0. Okay, I need to solve that equation. Right, how shall I solve that equation? Well, I'm going to factorize the left-hand side. So I'm going to take out 2x. Leaves me with 28 minus 3x equals 0. So x could be 0, or x could be, let's have a look, 28 minus 3x would have to be 0, wouldn't it? So 3x would have to be 28. So x would have to be 28 over 3. Okay, well, obviously, x being 0 is a pretty rubbish answer because my cuboid can't have a height of 0 and a width of 0. So let's ignore that, and let's just use x is 28 over 3. That is the value of x, which gives me a maximum volume. And I'm asked to find what that maximum volume is. So I use my volume formula, which is 28x squared minus 2x cubed, and I substitute in x is 28 over 3. So the maximum volume is going to be 28 times 28 over 3 squared minus 2 times 28 over 3 cubed. Stick that in your calculator, get your answer. I got 813.037 and so on. So to 3 significant figures, 813 cubic centimeters is the answer. All right. You could have used the quadratic formula, I suppose, but are you really going to do that? I suppose you could. You'd have a is minus 6, b is 56, and c is 0, would you? Okay. correct. Okay. So what's the total surface area of the hemisphere? I don't know without looking at the front of the formula, of the front of the paper. Okay. Right. That is 2 examples of differentiation questions for you. Okay. All right. Time's getting on. We've got another half hour or so till I'm going to call it quits. We're going to look at a couple of graph questions now. Okay. So here we go. Here's a question about transforming graphs. Question 20. I hope that's large enough for you to see. Okay, have a go at that. Solve simultaneous equations graphically. Just draw both lines and see where they cross. I think that there are some similarity questions coming up in this evening, but I don't think anyone's sent any in for this afternoon, I'm afraid. But if I've got time, then I'll do one, I guess. Why do we need to add the circle base? Isn't it added? I don't know quite what the nicest possible way. I don't know what you're talking about when you talk about the circle base. Okay, if you've done part 1 and part 2, then you can have a go at part B there. Now, in this question, you've got a curve with an equation, and it has a turning point at -6, -4. Maybe it's here. Okay, I don't know, let's just draw it like that. Okay, right. Write down the coordinates of the turning point on the curve with the equation fx plus 5. So every y is going to be 5 higher. This curve is just moving 5 up. So the minimum point is going to be simply 5 higher. So it's still going to have an x coordinate of -6, but its y coordinate will be 5 higher than -4, so will be 1. So -6, 1 is the answer there. Now, you need to remember that if the change is outside the bracket, then the curve goes up or down. Okay, that's what we've just done. Now, if the change is inside the bracket, then the change happens the wrong way. So you would expect, if we're timesing by 3, you'd expect everything to get 3 times bigger. It doesn't, it gets 3 times smaller. So the x coordinate was -6, -4, and now the x coordinate will be -3, -2, -4. It gets 3 times smaller. Okay, I wish I had time to kind of teach you that, but I don't. It's just a rule to remember. Now, in this case here, we've got y equals g of x, and we need to sketch the graph of y is twice g of x. Well, all we're going to do here is double each of the y coordinates. So if we have a look at this point here, at that point, when x is 4, g of x is 0. Well, twice g of x, twice 0, will still be 0. So it's going to go through here. Okay? And in the same way, when x is 2, g of x was 0, so twice g of x will be twice 0. 0. So it still goes through here and here. Now, let's have a look at this point here, which I'll mark in green. When x is 0, g of x is 2, so twice g of x will be 4. So we're going to go through the red points and through that red point there. When x is 8, g of x is 4, So twice g of x will be 8. So it'll be up here. When x is 3, g of x was minus 1. So twice g of x will be minus 2. So I think you get the idea now. My new curve will be this one. There it is. Okay. All right. All the y values are doubled. Okay. Right. So that's question 20. Okay. All right. That's exactly right. The change happens inside the bracket. You go the wrong way. Okay. All right. Okay. We are moving on to question 21, where you're given a curve and you need to use that curve to solve two equations. The first one is easier than the second one. Okay. Have a look. Are you allowed to draw out? Yes, I think you're allowed to draw out of the box on the graph. Just get the answer. It would be a stretch in the y direction by a scale factor of 2. Yes, it would. They really will give you tracing paper if you ask for it. Yes, because you'd need it if you were doing a rotation. Okay. I don't think I've done a graph transformation film on the channel, I'm afraid, but I only started the channel in September, so I'm sorry that not everything is there yet. The total surface area of a hemisphere using the sphere total surface area formula. Yes, well, the surface area of a sphere, imagine a tennis ball. Okay, the surface area is all the outside of the tennis ball, all the green felt, right? If you had a hemisphere, cut the tennis ball in half. Now you've got half the green felt, but you've also got a circle, a new face, which is the circle, which is on the bottom of the hemisphere. So you'd have to add the area of that circle. Now I understand why you're all talking about hemispheres. Okay. Right, part of the graph of that equation is shown on the grid. Use the graph to find estimates for the solution of the equation 2x squared minus 4x minus 1 equals 0. So what I'm going to do here is I'm going to draw two graphs. I'm going to draw y equals the left-hand side, which is, by the way, already drawn for me. That's why they're asking you this question. And I'm going to draw y equals the right-hand side, which is y equals 0. And then the solutions to the equation are going to be where those two lines cross, are going to be the x coordinates of the points where the two lines cross. So there's the line y equals 0. And so you can simply read off the x coordinates of those points. So my solutions would be minus 0.2 and 2.2. Okay, and that is part A done. Now, I'm just going to pause for a moment because I'm about to delete that and then have a look at the slightly more difficult second bit. Okay? Right. So let's get rid of that little lot. Okay. Part B. By drawing a suitable straight line on the grid, find estimates for solution of this equation. X squared minus x minus 1 equals 0. Now, on the grid, you have the graph of 2x squared minus 4x minus 1. So you really want to turn this left-hand side into the expression that you've already got graphed. Okay, so we are going to do what we need to do to both sides of this equation in order to turn the left-hand side into this expression, which I'm shading in blue there. How are we going to change top left into that blue expression? Well, my x squareds need attention, don't they? Because I've got 1x squared in the top, and I want that to become 2x squared. So the first thing I'm going to do is I'm going to double the left and double the right. So now I have 2x squared minus 2x minus 2 equals 0 times 2 is 0. Right. Now I've got my x squareds as I want them. But do you see how I've got minus 2x? And I really want minus 4x. So I'm going to minus 2x from both sides. And do you see how I've got minus 2 and I really want minus 1? So I'm going to add 1 to both sides. So I'm going to minus 2x and add 1. So on this side I have to minus 2x and add 1. So on the left-hand side, I'm now going to have 2x squared minus 4x minus 1. And on the right-hand side, I've got minus 2x plus 1. Now, why did I do that? Well, if I want to solve this equation, which I'm putting that yellow blob next to, then I have to draw two lines. One is y equals the left. Oh, that's the line I've already got drawn. And the other one is y equals the right. So all I need to do now, because I've already got the first line drawn, is draw the line y equals 2x plus 1 and see where my curves cross. Now, the line y equals 2x plus 1, it goes through 1, and it has a gradient of minus 2. But look out, because they've made the scales different on the x and the y-axis, just in case you thought that they were going to make it easy. So if I'm doing a gradient of minus 2, I have to go along 1 and down 2, but you make sure that you go along 1 on the x-axis scale and you go down 2 on the y-axis scale. I don't know why they insist. I think I've got that wrong, have I? I think I've got that wrong. Let me try again. You go along 1 on the x and down 2, along 1 and down 2, along 1 and down 2. That looks better. Right. Why they have to add that little complication is anyone's guess. So now I've drawn y equals the left and y equals the right, and the solutions to the equations are the x-coordinates of the points where the two lines cross. So my solution is going to be 1.6, that's the x-coordinate of this point, and minus 0.6, because that's the x-coordinate of that point. And there you go. Okay, so what I did was I took the equation they gave me to solve, and I manipulated it, doing the same to left and right, so that I changed the left-hand side to the graph I'd already drawn, because then I was able to draw the graph on the right-hand side and find the points of intersection. Okay, all right. One more question. Simultaneous equations. Here is, now, I can't remember exactly what came up on each paper, but I think we're expecting quadratic simultaneous equations on both papers. Okay, so here is an example of where you have to solve two equations simultaneously, but one of them is a quadratic. So you have a go at that while I look at the comments. Yeah, I'm quite embarrassed to say that I like simultaneous equations too. Okay. Right. I'm just sorry to laugh, but we spent ages doing lambdas and mu's about an hour ago. Okay. Why do we need to get two equations there? But I'm not quite sure. I don't understand your comment, Gloom Knight. We need to find where. Sorry, you're talking about the previous question, aren't you? What we're doing on the previous question is we're plotting two lines and seeing where they cross to find the solutions of the equation. I don't think I've explained that very well, I'm afraid. Why didn't I include x squared in the straight line? Because there wasn't an x squared, because I doubled left and right. which gave me 00 on the right. The drawing a suitable straight line, what's that topic called? It is solving equations graphically, I suppose. It's using as one of the ways in which the exam board expect you to use nonlinear graphs, using graphs to solve equations. Oh dear, you timed it really well, Ginger Mathematician. We've just been tying ourselves in knots with lambdas and mu's. Okay, and we're on the last question now. I just joined. How long till the answer will be revealed? Oh, well, the question we got on the screen. Well, I'll do it in a couple of minutes, I should think. This is the last question which folks sent in. So then I'll have a look at my email in case people have emailed any questions while we've been going. Okay, right. So in this question, we're given two lines. We've got one with an equation y equals x plus 2, and another which looks a bit more complicated here. Okay, all right. It's actually a circle, but that doesn't matter for the context of this question. You need to find the points, the coordinates of the points where these two lines cross, where the line intersects the curve. Okay. So essentially what we're going to do is we're going to solve these two equations simultaneously. So the first equation is y equals x plus 2, and the second equation is x squared plus y squared minus 2y equals 24. And we're going to find the values of x and y, the point which satisfy both equations, the point which lies on both of the curves or the lines. So I'm going to take this expression for y from equation 1 and substitute it into equation 2. And once you've worked out that that's what you've got to do, the mission is don't mess your algebra up. So I've got x squared plus y squared. Well, y squared is x plus 2 squared. Minus 2 times y, so that's minus 2 times x plus 2. And that equals 24. So that is x squared plus. Now I'm just going to take my time here because I can do this question. So there is no way I'm going to mess it up. So I've written out x plus 2 squared as x plus 2 times x plus 2, just as that's going to help me not mess it up. Now multiply out this bracket, minus 2x minus 4 equals 24. So that is x squared plus, right, x squared plus 2x plus 2x plus 4 minus 2x minus 4. I really am taking it steady, because there is no way I'm losing marks on this question. Tidy up the left-hand side. X squared plus x squared is 2x squared. Plus 2x, that's 4x, minus 2x, that's plus 2x. Plus 4 minus 4 disappears, equals 24. Right, that's a quadratic equation. Let's set it equal to 0 by subtracting 24 from both sides. And now let's solve it. Well, I could factorize it. I'm going to divide everything by 2 first. Look at that. That's a bit easier. And now I could either factorize it or use the formula. I'm going to factorize it because I can see that that's going to be x plus 4 and x minus 3. So my two values for x are minus 4 or 3. Okay. So let's just have a quick look at what we've done so far. We took the expression from equation 1. We substituted it into equation 2, and we have managed, therefore, to end up with an equation which just had x's in it, which we've solved. Okay, so I know my two values of x. So now I'm going to use my equation number 1, y equals x plus 2, to work out each x's corresponding value of y. So if x is minus 4, then y is x plus 2, so that's minus 4 plus 2, which is minus 2. So that point is minus 4 minus 2. And if x is 3, then y is 3 plus 2, which is 5. So that point of intersection is 3, 5. And those are the coordinates of the point A and the point B, minus 4 minus 2 and 3, 5. Okay, right. Well, I'm pleased that's what you got, because that's what I got too. Vectors, please. Right. Right. I think I'm going to struggle now, because Serge, you always need to simplify fully what? Okay, right. So I suspect that people would like to do another vectors question, because that is something that has been asked about. Okay, and also we haven't done any kinematics. All right. Okay, so I am going to pause for a second, and I'm going to look at my email. And if there is a question, I've got 10 more minutes basically. So if you would like to email through a question, then I will choose one or two of those that you email. Okay, and I will we'll do them together. Okay. Right. Okay, I'm just waiting for anyone to email me a question, really. So let's have a question on vectors or a question on kinematics, perhaps, because those are two topics which people have been asking about. We haven't done any trig today. Do we need to know kinematics? I've never learned it. You probably have. It's when you use differentiation to work out problems around acceleration and velocity and displacement. But if it does come up, it will be it'll be on the more difficult end of the paper, and it'll be worth 3 or 4 marks. So if you haven't done it, don't worry about it. Now's not the time to start learning something new. Okay. It probably won't come up. If it does, it won't be worth 1,000,000 marks anyway. Okay. Right. Okay, now. Right. Somebody sent in a 3D trig question. Oh, and there's a nice question as well on fractional indices. I don't think we've had a question on fractional indices yet. Okay, so I know that whatever I do won't suit everyone, but here are 2 questions that we can finish on. Okay, you can see them both on the screen there. As I say, I'm sorry if it doesn't suit everybody, but we can't do everything. And there are 2 questions for us to work on. They're both topics which we haven't looked at today, so that's quite good, at least. All right. Okay. In which questions are we not allowed to simplify our fractions? You can simplify your fractions in every question. Don't worry about that. Okay. We're going to finish in 10 minutes, okay? All right, so then you can go and eat. You can go and eat anyway, all right? Okay, now I'm pretty sure that there are some vectors questions coming up in my 6:30 Zoom, but look, there are lots of vectors questions on the channel. I'll see if I can't find a link to the vectors film and put that on the chat, okay, while you have a look at the question which is on the screen. Okay. Right, if you want the Zoom link, if you want to join us at 6:30 this evening, you'll need to send me an email and I'll send you the link. That's a paid session. It's only £10, but it's a paid session. So so clearly you'll need to send me an email if you want to join that, and I will I'll send you details, okay? Right. So while you're doing those questions on the page there, I am just going to find a couple of links for you on the topics that you've been asking about that we haven't had time to do. Right, here's the vectors film. Okay, for those of you who want to practice vectors. Okay, I'm afraid the Zoom tonight isn't free, but you have had lots of stuff free, and it's only a whole £10. But no, sorry. But there is lots of stuff on the channel to help you. There's the vectors link, the film. If you want any links for any other topics, let me know in the next few minutes, and I'll stick them on the chat here. Okay. Differentiation, somebody's asked about. I'll put a differentiation link on. Thank you, anyone who sent me an email. I will reply to your email once we finish this next 10 minutes. Okay. Now I'll put the differentiation link on. Okay, the link for the differentiation playlist. And then I've got a film which will be really quite important, I think. Right. Differentiation. There you are, that's differentiation playlist. Past paper club. Well, normally it's about 12. It's been 12. We've been running since February, and it's been about 12. But there are a fair few coming this evening. Okay. Right. Now this is what I wanted to tell you about. So, checking your paper, right? You need to do a thorough job of checking your paper. It's so easy to miss out a question, okay? And it's so easy to miss out a page of questions, and it's so easy to fall into various other traps. And the trick is to check your paper several times, each time looking for something different. So you end up checking each question, say 4 times, rather than checking each question once, looking for 4 different things. You check each question, you check the whole paper through 4 separate times, and each time you look for a different thing. I don't think that made much sense, but here is my how to check your paper film. Okay, and I know that you want to do all sorts of things and join all sorts of things for free and all the rest of it, okay? But if you watch that checking film, that could well get you 5 or 6 extra marks as well, which might take you to the grade up. I'm not sure what my age has to do with anything, okay? It's safe to say I did O-levels, not GCSEs. Right, okay, here is a question number 22. Let's have a look at that one. Why can't you see the links in the chat? They're coming up by somebody called BFC is putting them in. Okay, they're not coming up. Just put one up. They're really being filtered out. Why would links to YouTube films be filtered out? Oh, thank you. So some people are getting it then. Okay, if you're not getting the links, then you're allowed to simplify your final answers in every question if it's a fraction. Okay? YouTube filters out links and email addresses. Okay, I'll tell you what I'll do. I will put the links to the useful films in the description of this free live film, and the free live film will appear on the channel, as soon as we finish. It normally appears 5 minutes later under the live link. Okay? So I will edit the description to include those links. Right, okay, we're going to do question 22. It's the one on the screen. Okay. Right, I haven't looked at this question before, but we've got a flagpole, BF. is vertical, and we've got some measurements there of a triangle. BF is vertical to the ground, and the ground's obviously horizontal, so that's a right angle there. The point D is on AC. Wait a minute, D is the point on AC such that BDC is at right angles, right? So I'm going to add this line here. Okay, that is the point D, that is a right angle. Work out the size of the angle of elevation of the point F from the point D. So you are being asked to analyze the triangle here. Right, let me draw that out. That's the triangle from F down to B. And then you go along to D. Okay. And you've got a right angle here because that's the flagpole. The flagpole's 10 high. Okay, and you're being asked to work out that angle there, the angle alpha. Now to do that, it would be really nice to know the length of BD. Now BD is this green line here. How am I going to find the length of BD? I did think I could use Pythagoras, but that 16 is the whole length from A to C, so that's not going to help me very much. Okay. Why am I struggling? How can I work out the length of BD? Somebody tell me in the comments, please. Okay. How am I going to find BD? Why am I finding this so difficult? AC is 16. Why can't I find BD? Do I need to use the sine rule or the cosine rule on that triangle ABC? Come on, somebody, help me out. The cosine rule to find angle C. Oh, well done. Very good indeed. Thank you very much. Thank you. That's exactly right. So we're going to use the cosine rule to find, so we're going to use the sine rule. No, we're going to use the cosine rule to find angle C. Thank you. So to use the cosine rule, it's going to be 9 squared equals 11 squared plus 16 squared minus 2 times 11 times 16 times cos the angle C. So we're going to use a bit of calculator button pressing here. So I'm going to have 81 equals, so I've got 121 there, 121 plus 16 squared. Okay, so that gives me 377 minus 2 times 11 times 16, 2 times 11 times 16. That's 352 cos C. Okay. So that's going to give me 81 minus 377 minus 296 equals minus 352 cos C. So cos C is going to be 296 over 352. So let's have a look at that. 296 divided by 352. And then I'm going to shift cos. That gives me an angle of 32.8. Okay, so that's this angle here, 32.8. So now I believe, thanks to whoever it was who told us how to do the question, that I can analyze triangle B to D to C. So that is 32.8. That is 11. And so now I can find BD. Let's call that X. Okay, I'm going to use sine here. I'm finding the opposite. So X is going to be 11 times sine 32.8. Okay, so I've got 32.8 on my calculator, so I'll sign that and times by 11. So x is 5.95, so BD is 5.95, and now I can use tan to find that angle alpha. 10 over 5.95, so I'm going to do 10 divided by 5.95 equals, and then shift tan equals 59.2, I get. Okay, all right. So I think that is that question done. And now we're going to finish off with 15a. Okay, here it is, 15a. Right. Okay. Thank you very much. Who was that who told me to use the sine rule? You had it sorted. Okay. Very good. Okay. Now, to do 15a, you need to remember what this fractional power means, this fractional indice. Okay. It's a power of 3 over 5, so you're going to cube it and find the fifth root. Okay. Now, it doesn't matter which way around you do them. Okay. So we've got 32 a to the 15. All right. And that's the power of 3/5. So perhaps the first thing to do is to find the fifth root of each of those. Now, I bet the fifth root of 32 is 2. 2, 4, 8, 16, 32. Yes. So the fifth root of 32 is 2. Now, the fifth root of a to the 15. Now, be careful. Okay, the fifth root of a to the 15. All right. What multiplied by itself 5 times will give you a to the power of 15. Now remember that you add the powers, so actually it's going to be a cubed, because a cubed times itself 5 times is a to the 15, so that's a cubed. So when we fifth root it, we get 2a cubed, and so now we have to cube that. 2 cubed is 8, and a to the power of 3 to the power of 3 is a to the power of 9. And that is the final answer on this live session, and it is 8a to the power of 9. And reassuringly, I agree with most of you lot, which is great. Right, okay, so I'm going to call it quits there. Thank you very much for coming. If you would like to send me an email to find out about the 6:30 session on Zoom, then please do. I will, once I've finished, I will edit the description of this live film to include those links that I mentioned. Okay, but you've got my email address, so I'm sure you can email me if you need to. Okay, thanks very much for coming. I'm going to stop sharing the screen. Okay, and I tried to stop sharing. Oh, there we are. I'm going to stop sharing the screen, and very good luck for tomorrow. And for many of you, I'm guessing that tomorrow might be your last maths exam ever. Those of you who are continuing on to year 12, lots of you on the channel have said what happens in year 12, etc., etc. So I'm going to do a year 12 corner on the channel, okay? And I'm going to share the films which I use at school with my year 12s. Okay, is A levels hard? Well, essentially, if you're getting a 7 and 8, 9, then you're certainly worth giving the A level a go, in my experience, as long as you enjoy your maths. Okay, all right. I'm going to end the stream. Thanks very much for coming, and I will see you tonight if you're coming tonight. Otherwise, I'll put a film on the channel to ask you how your paper goes. Okay, right. Okay, let's just deal with these questions now. Do I do A-level content too? Well, I teach year 12 at school, so the year 12 and year 13 stuff, which I do with them, I tend to put on YouTube, so I'll merge the two channels. Okay, all right, that's it. It's all over. Thanks very much for coming.